Hello, in this lecture we will find the size of 2 times AP. Okay, you can see in the picture triangle ABC with side AC that equals to 70 units, side BC equals to 50 units, and side AB equals to 90 units. And also the center of the circle is P, and actually side AC of the triangle tangents the circle, and also side BC of the triangle tangents the circle in other point. Okay, so first of all we will connect points P and C by a line. As I've already said, point P is the center of the circle. We also will connect. We will also, first of all, we will call the touching point between side BC of the triangle and the circle. We will call it S, and also we will call the touching point between side AC of the circle and the circle D. Okay, I repeat again, the touching point between side BC of the triangle and the circle is called S, and the touching point between side AC of the triangle and the circle is called D. Now we will connect points P and D together. Actually, PD is also the radius of the circle we'll call the radius of the circle R. Also, we'll connect between points P and S. And PS is also the radius of the circle, as you can see from the picture. So the touching point between side AC and the circle is D. Okay, well, I will change it to capital D. Okay, now is more clear. So PD is the radius of the circle, and PS is also the radius of the circle. Now, actually, we have a rule that if we have a circle and from external point of the circle we will make two tangents to the circle. So M is external point of the circle, and from point N we drew two tangents to the circle. Okay. Let's say that the tangents point between the line and the circle here is L, and the tangents point between the line and the circle in the other side will be called F. So the rule is that MF equals to ML. Okay. So from external point of a circle we drew two tangents to the circle, and the one point the point of the tangents of this line is F, and the point of tangents of line of this line is L. So the rule is that MF equals to ML. So therefore in our picture according to the rule that I told you about it, actually CD will be equal to CS, because from external point of the circle we drew two tangents to the circle, and the rule is that those two tangents to the circle equal to each other. So we can write that CD equals to CS. Again, CD equals to CS, according to the rule that I mentioned. Okay, so, and also, as I already told you, PD is the radius of the circle, and also PS is also the radius of the circle. So we can say that PD equals to SP, or PS is the same. PD equals to PS equals to R, because it is the radius of the circle. And of course, PC equals to PC. Therefore, triangle PDC congruent to triangle PSC. According to the rule that if two triangles have three sides that equal to each other, then they are congruent to each other. Okay, so triangle PDC congruent to triangle PSC. Again, triangle PDC congruent to triangle PSC. Okay? Because they have three sides that equal to each other. As you can see in the picture, side DC in this triangle equals to side CS in this triangle. Side PD in this triangle equals to side PS in this triangle, and side PC equals to itself. So three sides of one triangle equals to three sides of the other triangle. So those two triangles congruent to each other. Okay, so, and therefore we can say that this angle equals to this angle, according to the rule of corresponding angles between congruent triangles are equal to each other, because of the fact that this triangle congruent to this triangle, it must be that this angle equals to this angle, according to the rule that corresponding angles in congruent triangles equals to each other. So if we call to angle DCP theta, then angle PCS also will be theta, because they are equal to each other, according to the rule of corresponding angles in congruent triangles are equal to each other. Okay, so we can write that angle DCP equals to angle PCS. Okay, theta equals to theta. Okay, angle PCD equals to angle PCS. Okay, now we will draw triangle ABC again. In triangle ABC, we have line PC. P is the center of the circle, but side PC, actually the line PC bisects angle ACB to two equal parts, because this angle is theta and this angle is also theta. So we can say that line PC bisects angle ACB. Angle ACB, it creates two equal angles. Okay? So according to bisector theorem, if a line bisects angle to two equal parts, then actually it creates the following relation between the actually it creates a special relation on the side that it touches. and we can say that AP over BP equals to AC over BC. Okay, so according to bisector theorem, if a line divide an angle to two equal parts, then it creates the following relations between the following sides: AP over BP equals to AC over BC. Now we can call AP, we can define it as X, and it is given us that AB is 90 units. So if AP equals to X, then BP must be 90 minus X, because it is AB minus AP equals to BP. And it also given us that AC equals to 70 units and BC equals to 50 units. So in equation 1, AP over BP equals to AC over BC, we can substitute AP by X, because AP equals to X, and PB we can substitute by 90 minus X, because they equal to each other. BP equals to 90 minus X, so we can substitute BP by 90 minus X. So instead of AP, we can write in the first equation X minus BP, BP equals to 90 minus X. Equals to AC over BC. But we know that AC equals to 70 units. So instead of AC, we can write 70 units over BC. BC, the size of BC is given. It is 50 units. So instead of BC, we can write 50. Okay. Now, $70 equals to 7 times 10, and 50 equals to 5 times 10. So we can write in equation 1 that X over 90 minus X equals to 70. Instead of 70, we can write 7 times 10, because 7 times 10 equals to 70, over 50. 50 is 5 times 10. So instead of 50, we can write 5 times 10. And actually, here we can cancel 10, because we have 10 in the numerator, and also we have 10 in the denominator. Okay, the denominator. So we can cancel 10. Okay, and after we will cancel 10 in the numerator and denominator, we will get that x over 90 minus x equals to 7 over 5. Okay, so after we cancel the 10s in the numerator and denominator, we got here 7 over 5 equals to x over 90 minus 6. Now we can multiply by 5. We can multiply by 5 both sides of the equation. So we will get that five x over 90 minus x equals to 7. Okay? After we multiplied by 5 both sides of the equation, we got that 7 divided by 5 times 5 equals to 7, and x over 90 minus x times 5 equals to 5x over 90 minus x. Now we can multiply by 90 minus x both sides of the equation. And as you can see in the picture, actually x is less than 90, so 90 minus x is a positive number. It can never be zero. So for that reason we can divide both sides of the equation by 90 minus x. Okay, so we will get that five x equals to 7 times 90 minus x So after we multiplied both sides of the equation by 90 minus x, we got that 5x divided by 90 minus x times 90 minus x equals to 5x, and 7 times 90 minus x equals to 7 times 90 minus x. Now we will open the brackets. We will get that 5x equals to 630 minus 7x. So we open the brackets. 7 times 90 is 630, and 7 times 6, 7 times minus 6 equals to minus 7x. Now we can add 7x to both sides of the equation. We'll get that 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Okay, so here 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. Okay, so we'll get that 12x divided by 6 equals to 2x and 1630 divided by 6. We will do it in the next step. So we divided both sides of the equation by 6. 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. So we will write that 2x equals to 105. Okay, so actually, as you can see from the picture, x equals to AP. Okay, x equals to AP, so we write it down. X equals to AP. So if x equals to AP, 2x equals to 2 times AP. Yes, 2x equals to 2 times AP. Okay, x equals to AP, so 2x equals to 2 times AP. And 2x also equals to 105, so we can write it 2x equals to 2AP, and it also equals to 105, so 2x equals to 2AP, and 2x also equals to 105, so we can write here that 2x equals to 105, or 2AP equals to 105. So that's exactly what we were looking for. We got the answer that 2 times AP equals to 105. Okay, so again, 2 times AP equals to 105. So we can summarize the lecture. Actually, we wanted to know the size of 2 times AP, and according to the rule that if you draw 2 tangents from external point of a circle, those 2 tangents equals to each other, so we can say that CD equals to CS, and P is the center of the circle. So if we connect points P and S, we will get the radius of the circle, and we can connect also points P and D, and this also will be the radius of the circle. So we can say also that PD equals to PS. So, and PC equals to itself. So we have here 2 triangles that are congruent to each other because they have 3 sides that equals to each other. This side in this triangle equals to this side in this triangle. DC equals to CS. This side in this triangle equals to this side in this triangle, or DP equals to PS. Both of them actually the radius of the circle. And side PC equals to itself. So we have 2 triangles that have 3 sides that equals to each other. So they are congruent to each other. They overlap each other. And because of the fact that those two triangles congruent to each other, we can say that this angle equals to this angle, according to the rule that corresponding angles are equal to each other in congruent triangles. We have congruent triangles, and in congruent triangles, corresponding angles are equal to each other, and this angle corresponds to this angle, so they are equal to each other. So if this angle is theta, this angle is also theta. And if we look now on triangle ABC alone, in triangle ABC we have line PC that actually divides this angle to two equal sides. This angle equals to this angle, and according to bisector theorem, the following relation are true for the sides that x divided by 90 minus x, or AP divided by BP equals to AC over BC. Okay, so according to bisector theorem, if in a triangle ABC we have line that bisects this angle to two equal sizes, then the following relation is true, that AP over BP equals to BC equals to AC over BC. Okay, again, AP over BP equals to AC over BC. Why? Because this line PC divides to this angle to two different parts, to two equal parts. Therefore, it creates the relationship that AP over BP equals to AC over BC. But if we call AP x, then BP will be 90 minus x. So we can write instead of AP over BP x, that equals to AP, and we can substitute also BP by 90 minus x because they are equal to each other. So we can write that x minus 90 over x equals to AC, that is 70, over BC, that is 50. So we have here one equation with only one variable, that is x, and we can solve it very easily. And we found out that x actually, or 2x actually equals to 105, and x actually equals to AP. So 2 times x is 2 times AP. So 2 times x equals to 2 times AP, that equals to 105. So the answer to the question is, what is the size of 2 times AP? Is that the size of AP is 105 units. Okay? Thank you very much.